Hi, this is the second video discussing a problem on special relativity. Today's video will be talking about time and proper time. It's very important that you watch the previous video before doing or watching this one. I will leave the link to the previous video, the first one, down in the description. So let's look now at the problem. We have two observers. John, he is in a spaceship, and the spaceship is moving with a speed 0.6 times the speed of light relative to Ali, and Ali is located at point A. The length of the spaceship when it is at rest, so that's the proper length of the spaceship, is 225 meters. Now we are not gonna repeat what I did in the first video, so let's go directly to the question in this video. The question is, which observer, Ali or John, measures the proper time that is needed for the ship to pass Ali? Once we understand this and answer it, then we will try to find the time needed for the ship to pass Ali as measured by both observers. Let's go back to the first question. The question is asking which observer. We have two observers, Ali and John. And remember, John is sitting inside the spaceship. Which one of them will measure the proper time that is needed for the ship to pass Ali? Let's try to analyze this problem from Ali's perspective. Now, the spaceship is moving, and we want to look at the time measured by Ali for the spaceship to pass Ali. Now, what that means? Let's say at particular moment for Ali, the tip, that's the front tip of the spaceship, is touching his foot. So let's call this the beginning of the event. Now, as the spaceship moves upward, finally the backward side or the bottom side of the spaceship will pass Ali's foot again. Now notice that for Ali, the beginning of the event and the end of the event, both of them are happening at the same location for Ali. Now, if you have an event that starts and finishes at the same location, then that time we call it proper time. That means Ali is measuring proper time for the spaceship to pass by him. Why? Because the beginning of the event and the end of the event, both of them are happening at the same location for the observer Ali. So we can answer this question now saying that Ali is the observer that will measure proper time. If we agree on this, let's try to find what is that time measured by Ali. So now for Ali, he will try to use simple equations. Now Ali already he knows the speed of the spaceship, and also he measured the length of the spaceship. So he's gonna use a simple equation to calculate time. He will say T is equal to the length of the spaceship as measured by him, which is the contracted length. If you watch the previous video, then you know that Ali will measure the length of the spaceship relative or by him divided by the speed of the spaceship. Now in the last video we found L to be 180 meters, and that we will divide it by 0.6 times the speed of light. Plug in numbers, you can easily find the answer And the answer is 1.0 times 10 to the minus 6 second. Now that ends the calculation with respect to Ali. Let's now look at John's perspective and let's try to see what John will measure. So now let's look at the same problem from John's perspective. Now John is sitting in the spaceship. Let's say he's sitting in the front of the spaceship. He's looking outside and he's seeing Ali moving downward with the speed u. Now for John, the beginning, let's say the event will start when the tip of the spaceship touches Ali's foot. So that's the beginning of the event. Now for John, he sees Ali going down. Now the event will end when Ali's foot will touch the bottom side of the spaceship. So now you can see that for John, the beginning of the event is at the tip of the spaceship and the end of the event will be at the bottom side of the spaceship. So for John, he's seeing the event starting and finishing at two different locations. And that means the time measured by John is not proper time. So that's not the proper time. Now time for John will be now, let's try to calculate that again. This is done easily. For John, he knows the distance, which is the length of the spaceship. According to him, this is the proper length. So that's, let's call it L0, divided by the speed of Ali. Now L0 is 225 divided by the speed of Ali, which is 0.6 times the speed of light. Simple calculation will give you the answer, and the answer will be 1.25 times 10 to the minus 6 second. So now we can see that John is measuring a little bit bigger time than Ali. Ali is measuring proper time. John is not measuring proper time. Now we can relate the two measurements using a simple relation, which is the time dilation equation. We know that John is measuring this time, while Ali is measuring, let's call it T0, the proper time, which we found to be 1.0 times 10 to the minus 6 second. Now we can relate those two by the time dilation relation, which says that T is equal to T0, the proper time, divided by 1 minus the speed, the relative speed between the two observers, divided by c squared. And you can check easily that the equation is satisfied. This is the end of this video. I hope you understand it. And if you have any comments, please leave them in the comment box. See you in a new video. And thank you for watching.